presentation. My name is Jiri Dobes, and I'm the Head of Solutions in the Johnson Labs.
Hello, everyone. Welcome to the summit. This is Veysel, Kocaman, Head of Data Science, leading the Healthcare NLP team at Johnson Labs.
Okay. Our presentation is about automated medical data de-identification and obfuscation. I will shortly introduce motivation, background, why do we do the identification, what is behind. Then I will show what are our de-identification capabilities, what we can do, and then Veysel will present technical solution and how do we stand in terms of benchmarks. Right, why we do de-identification? First of all, there are globally increasing privacy concerns. We see it in the US, where there is a HIPAA privacy rule already for 20 years. We see it in European Union, where there is GDPR, but we see it also in other regions, like in Canada, Australia, etc. On the other hand, we see also increasing volume of data, or not like increasing, but it's like explosion of data, because it's grows in volume, but also grows in specifically in the healthcare, and the growth in the healthcare is much higher than in other sectors. And we see improving NLP capabilities. So over past few years, every 2 years was like 1% decrease of the errors. And the identification already surpassed the capabilities of humans on the same task. So how the HIPAA works? There is a HIPAA. HIPAA is specified that there is a privacy rule, and in privacy rule there is a specification or rules what we can do or what we cannot do with PHI, with protected health information. So first of all, the protected health information we cannot even use or we cannot disclose, except few permitted cases, like for example, running hospital, running healthcare system, etc. You can do, but you cannot use it for the analytics, you cannot use it for the training, machine learning models, you cannot use it for most of the interesting use cases. However, if you remove protected health information from this data, you can use it, but you cannot disclose how to re-identify this natural person or pre-identified natural person, and then there are some other requirements that you should not or we cannot disclose, and then it's considered de-identified, and it needs to satisfy certain rules. And the rules are that the information which doesn't identify, and there is also no reasonable basis to believe that can be used to identify individual. And the second rule is that it must be either expert determination or safe harbor. Expert determination is like using expert who uses generally accepted statistical methods to determine that it's not a reasonable basis to identify, and you need to document this method and the results. And the second option is safe harbor, and safe harbor is like removing of 18 specified identifiers. In Europe, there is a similar situation, but it's more fuzzy or more like generic specification. So we should, to determine if the natural person is identifiable, we should take into account all means reasonable likely to be used. It cannot be identified directly or indirectly. And we also should consider cost and the amount of time required for identification, and also consider available technology. And if the protected health information are removed, then there is the documents are not covered by GDPR anymore, and it can be freely shared. Let's look at where we are in terms of human capabilities and where we are in terms of NLP capabilities, specifically in healthcare NLP of the last. Humans are maybe not as accurate as you may believe. That if you have one person removing PHIs from the documents, he would do roughly 20% misses. If you have two people, they can do like 6% error, so 94% would be correctly removed. On the other hand, if you use healthcare NLP, what Veysel will be presenting in a minute, you can go somewhere in a 98%, 99, or almost 99% recall. So if you look to the decrease of the error rate, it's basically from 6% to 2%, so it's like 70% less errors if you use healthcare NLP than if you would have processes to scaled and motivated reviewers for the removing the PHIs from the documents. And also it allows to do the identification at scale, because more and more often we see that we don't de-identify only few documents, but basically de-identify first everything and then do some analytics. There could be question why or how does it work, like that if the process needs to be like 99%, 999 compliant, etc. So as I mentioned, with the humans, you are, let's say, with two people, 94% accurate. With healthcare NLP, we're almost 99% accurate, but you are not 99.99% accurate. There are some, you can see somewhere in documentation that it is yes, but then you need to consider what exactly you measure. If you are measuring the tokens which are going to identify, or if you are, for example, measuring the all tokens which you have in the document. And if you are measuring correctly the identified tokens in the document, then you can be 99.99, for example. So it depends on the exact definition. How do you measure, what do you exactly calculate in accuracy? All right. Let me now go back to healthcare NLP, to the Johnson Labs. For that, what we can do, we can de-identify basically many types of documents, like text documents, PDFs, searchable or readable, text readable documents. You can do Office, Microsoft Office, JSON format, etc. We do images. And we support currently 7 languages, but the other languages are coming based on the requirements from the customers. There is few ways how to de-identify. We just go quickly. Veysel will go into more details later. First of all, is masking. So it is replacing PHI information with some constant string, like for example stars, or just the name or type of the token. Second type is obfuscation and faking. The advantage of obfuscation and faking, it is not obvious on the first side that what was the original PHI document or PHI token there, or what is the replaced token there. So we take some random data from the dictionary, which looks similar way as it was in the original set. And we can do similar things for the documents, like in PDFs or DECOM documents with the masking. So replacing the PHI with rectangles. So now we go to more technical part of the presentation. So over to you, Veysel.
Okay, thank you, Jiri. So, in this section of I will cover the technical benchmark of the Spark NLP for healthcare the identification solutions, and I will also briefly show how we accomplish these metrics that you see on my slide right now. So, first of all, Spark NLP for healthcare right now supports 7 European languages, including English. Out of the box, and these are the metrics that we get. Basically, we have two sets of entities in the identification. It depends on the use case. For example, on the generic entities, we have 7 entities like date, name, location, as you see on the right hand side. So sub entities, which are the sub entities of each major entities. For example, name entities can be patient name or doctor name. So it depends how much granularity you would expect in your the identification. If it's just the identification like masking, it doesn't matter if it is generic or sub entities. But if it is, obfuscation, you need to replace the doctor name with the doctor name or street name with the street name because location could be street name, country, or just hospital name, right? So that's why we have a solution in Spark NLP for healthcare to get use of the rules as well, because there are some edge cases that we may not cover with the identification, like and then machine learning models. Basically, that's why we are stacking them together into one pipeline. So these are the metrics that you see on my slide, and then I'm going to share more metrics in a few minutes. But more or less in each language that we support, we are about 90% right now. In some of them, we are even about 98%. So in Spark NLP for healthcare, we have a pipeline concept. As you see on the right hand side is the one that we code when we want to modify this pipeline. But most of the time, whatever we ship as one-liner code, like dot load, dot pre-trained, clinical pre-trained model, and then you will be able to use it in without even understanding what's going on under the hood. But most of the time, if your data set has some peculiarities, and then some you need some customization, you need to unpack this pipeline so that you can use your own rules or own name identity recognition models. So how this works. So on the left hand side, you see that we take the document via document assembler and then split into the sentences, and then the sentences are split into the tokens. Now we need to find the type of the tokens, because name identity recognition is basically the token classification problem. So what we do is we have pre-trained name identity recognition models. Some of them are transformer based, some of them are LSTM, CNN, char based. We take the embeddings of each token and then the other features like char features, character features, casing features, and then send into the pre-trained models that we already trained. In Spark NLP, we have more than 150 pre-trained clinical NER models, but in the identification, we have 10 NER models because we only extract all these granular and sub-entities, as I showed in the previous slide. So in some edge cases, there are some rules that may not be extracted properly with NER models, or it would be too easy to extract with the rules rather than sending to the machine learning models, right? Like, for example, age, date, zip code, credit card numbers, SSN, etc. Like these kind of entities, I don't even need a machine learning, right? So that's why we decided to use rule-based parser, which we called contextual parser. And then we merge all of them and then send it to the identification engine. The identification engine job is to do the masking or obfuscation with the parameters that you specify in the pipeline. You can even apply day shifting, you can even apply some consistent day shifting, etc. There are many different features in that engine. So how we are doing in terms of each language, and with some specific entities, because because I just talk about the accuracy of the name identity recognition models, but we are improving the accuracy by applying some contextual parser, right? So we decided to see if it makes sense to use this kind of regex and contextual parsers on top of pre-trained machine learning models. So we pick age, date, ID, and location, which could be extracted with rules, so that you don't need a model for this. And then we compete with the pipeline version. Pipeline is like NER 91%, but when we use the rules with these NER models, it is 96, 97. So we have 5 to 6% boost here. When it comes to date, it is 1%, of course, but when it comes to ID, it is 4%. So if you see in just with the name identity recognition, English is 90%. But when I apply pipeline concept with the rules, it is about 96%. So for Germany, it is 95, Spanish 96, and in Italian, it is about 98, and Portuguese same. So if when it comes to binary PHI recognition performance, right? Because if you are doing masking, you don't need to precisely detect the entities if you are just masking, if you are just replacing all the sensitive information with some placeholder, some some mask, we call it masking, right? So if you do this, you may not need a granularity, and you don't need to specifically know if it is patient name or doctor name, if you are not doing obfuscation, of course. So we wanted to test this as well. By the way, we wrote an academic paper for this, and then published and then submitted a venue which is under review still, which is going to be published in a few months probably. So over there, with the binary PHI accuracy, we are almost like even in some languages we are about 99%. In Spanish it is 98, in English it is again 98, and Italian it is 99. So as you see, when it comes to masking, the accuracy is almost above 99% in almost all the other languages. So when we compare this with the academic benchmarks, like state-of-the-art papers, state-of-the-art results published by the researchers, for each entity, the dark blue ones comes from Spark NLP, like as you see, like data entities, hospital entities, streets, like these entities. Spark NLP is already doing well compared to the other entities, but in general, we are 3% better than the latest state of the art. So when we compare each language, like English, German, French, each spoken language across each other, and more or less you see that more or less they are similar, right? So for the data entities, the accuracies are almost same. For the age entities, again more or less. So they are more or less 5 to 10% range across each other. Of course, there are some different issues when it comes to German. For example, contact entity is is not that good. So that's why we are improving this with some rules by checking the test set or by checking the domain specific text that we are going to use in production. So when we do this, because as you know, in there are some cloud providers, commercial cloud providers like AWS, GCP, Azure. They have their own identification services as well, that you need to upload your data or use via API, and then it returns the mask or obfuscated version. So we wanted to check how we are doing against this giant cloud providers. So as you see, so Spark NLP for healthcare, at each one of them is already exceeding each one of the services in each entity type. So for example, data entity, we are already doing well, and age entities, same, hospital entities, ID entities. So all these entities, because as you see, there are missing bars here, because for example, hospital and ID, we have hospital entities for each cloud provider. What we don't have them, we don't have ID entities in GCP and Azure. Right, so that's why not all of the cloud providers offers the same granularity when it comes to the identification. So, and then the last part is obfuscation consistency, we call this. Obfuscation consistency is that when you try to replace all the sensitive information with the fake entities, you need to follow some rules to keep the consistency of the document, so that when someone reads that clinical note, they don't understand easily that this is already the identified, so that they don't try to reverse engineer and then try to re-identify this. So to keep the consistency of the document, because these documents, when you obfuscate and exchange with your colleague or with the other institution, they will need to use these documents for some purposes, right? If they are training a model by using this text, there needs to be some consistency over there to represent the reality. So that's why we ruled actually 6 different consistency rules, like name consistency, which means that if there is a Jane Doe as a name, the Jane always needs to replace with the same name across entire document. So we went ahead and then we did this for the across document as well. So if there's a if I know the ID of Jane Doe with the input, right? So I can do this for all the documents belonging to Jane Doe. So we call this name consistency. Same name will be always replaced with this with the same fake name. Given some hash key, we assign some hash key for each session so that you can manipulate this. It's like a seed. And then the gender consistency is you cannot replace Jane with John, right? Because there are some diseases that are feminine or masculine, right? So that's why it would disclose the identification and obfuscation. So that's why you need to keep the gender, you need to keep the use the gender specific names for the names that you want to obfuscate. And then the age consistency is you need to specify a range because you cannot just assign very old age to a baby if that clinical note belonging to like infants, right? So that's why you need to keep the usability of the document as much as possible so that the age should be consistent within some range. Clinical consistency is also feminine and masculine diseases, so you need to like Jane needs to remain female if she has, for example, a breast cancer history. So we call this clinical consistency. And day shift consistency, it's again specifically shifting the days based on the patient IDs, so that you don't always shift same amount of day when you obfuscate, when you replace the date with the fake dates. And date format consistency, sometimes it is just a proper date format, sometimes it is just April or the first day of July, etc. This kind of name date entities might appear over there. When you want to replace this, you cannot just replace this with some formatted proper dates, right? So you need to keep the same format so that it would look like original. And then the last one was length consistency, because sometimes for some technical infrastructure limitations, you may want to keep the same length of the entire document. Whatever you do, because some customers ask us that whatever we do on their document, it needs to be at the end of the day the same length of document, so that we keep this length consistency by applying some rules over there as well. So last of all, we have a live application that you can even right now go ahead and then try. It is johnsonolives.com/the identification. You can go ahead and then check this application. In this application, we shipped one-liner pre-trained clinical pipelines behind an API, and then we put it. We even added a language detection on top of this. As you see on the bottom left corner, there is a like a select language option. If you don't select the language, there is a language detection module coming from Spark NLP open source powering this application. You upload your text, or you just copy paste some text on the left hand side, and then you pick auto, and then you hit get like mask or the identify, and then you will be able to, like, the API will detect the language and then apply the corresponding identification pipeline to do the masking and obfuscation. As you see on the left hand side is the original text. On the right hand side, the first one is the mask version. All the entities are detected and masked. And then the right hand side is the obfuscated version. So the fake entities, like these masks, are replaced with the fake entities, so that at the end of the day, you have an original brand new document with no sensitive data inside. Thank you very much. I hope you enjoyed the talk. Please ask questions. We will be around to answer your questions.